Good afternoon, Stats. This is Mr. Kim, and I'm going to go over the study guide that I posted for you guys today. There are only about 7 questions here, so this video will be relatively short. And before I begin, I want to go over a couple of things. So 10 questions and 1 free response question out of the 2 that you're going to be chosen. So most of the multiple choice will look similar to the questions you see on this in this video. There will be consisting of a 6.1 expected value, 6.2, which is mostly combining the standard deviations and the mean. Make sure you know the formulas for those guys. And 6.3 is all about binomial, and then there's going to be geometric. I'll give you the FRQs based on one of the geometric and binomial questions we've done today, where there's 70% chance of something happening, and fixed number of trials or not fixed trials, and how to determine the using binomial PDF and CDF and things like that. There will also be a expected value / combining the random variables with the standard deviations and mean. We've done several FRQ questions dealing with the first 2. I suggest you guys take a look at the previous notes, previous work assignments I've assigned for you guys. And I think that should be good enough preparations for tomorrow. Number 1, middle school carnival has a guessing game where the standard deck of cards. And if you draw an ace, so the probability of you drawing an ace is going to be 4 out of 52, because there's going to be ace of diamonds, ace of hearts, ace of clubs, and ace of spades and ace of clubs. So that's 4 out of the entire 52. If he draws any other card, well, that means the rest of them, which is 48 out of 52. He loses 2 points and he gains 25 if he draws an ace. What is the expected win or loss for the student who plays this game 100 times, it says. All right, so first, what I'm going to do is I'm going to pull up my calculator on the side, and I'm going to write this for the following. It says that I'm going to win 25, but the chance of you winning 25 is only 4 out of 52. And you're going to lose 2 if you, there's a good chance of you actually being able to lose a 2, which is 48 out of 52. So what is the expected value? Well, you're going to just multiply those together. -2 times 48 over 52. And you're simply going to add these 2 values up together. And eventually what you end up with is that per play, you're actually expected to gain about 0.076. So I'm assuming that's about less than a point, less than 1/10 of a point. But you're playing that 100 times. So you're going to multiply that by 100, and you eventually end up with 7.69. So the player is expected to gain about 8 points, and that should be the correct answer. Number 2, in a popular video game, the chance of certain creature dropping a rare item, so the probability is 0.25. What is the closest probability that the rare items will be dropped 9 times or more? So we can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this all the way goes up to 30. Now, if we're talking about 9 times or more, we're actually talking about finding the probability of this. This is what we're interested in, which means I actually want to find out the probability of the rest of them. And this is going to be a binomial CDF. How do I know it's a binomial? Well, it says that there's going to be 30 creatures. The number of trials is fixed. So I'm going to do binomial CDF with 30, 0.25, the probability that the items will be dropped. And the number here would be 8, because it's going to be 8 or less that I actually want to get rid of from 100%. So if I pull up my calculator, I'm going to go to second VARs, do binomial CDF, a number of trials, probability is 0.25, and the X value is 8, paste. And then I'm going to do 1 minus that number, and I get 0.326 for that. All right, number 18, we are combining random variables. So we have the mean of 62 and a standard deviation. I'm going to call mean of X as 62 and a standard deviation of X, which is 1.0. Now, the weight of the packaging, that is going to be weight of just the packaging itself. That is a mean of 456 and a standard deviation of 6. I believe I should call this the weight of the smartwatch itself. So I'm just going to call that as W. Together, the distribution of the weight of the smartwatch and its packages. So we're combining these 2 together. We're talking about the weight of the watch and the packaging put together. So it's simply 456 plus 62, which will give you 518, which means I'm eliminating D and E because the mean has to be just combining those two together. Now, remember, the mean of the total would be mean of W plus the mean of P, the weight of the watch and the packaging. And now the standard deviation of the total is a little bit different. It's a square root of the standard deviation of the watch squared plus standard deviation of the packaging squared. And so I'm going to go to my calculator, 1 squared plus 6 squared. And I'm going to square root that number and I get 6.08. So the answer here should be C. Number 6, same thing, 650 for science, 465 for English. We're talking about the difference between science and English. So we want to find out the mean of science minus English here. The mean of science is 650. The mean of English is 465. So 650 minus 465, I think that should be 185 if I'm not mistaken. So that should be the mean. So I'm eliminating A and E so far. I'm going to do the same thing with the standard deviation of S, standard deviation of English, square them. I am still going to add them to figure out the rest of the science minus the English, because no matter what you do, whenever we were talking about variances, we're always going to add the variances together. So I'm going to go to my calculator once again. The standard deviation of the science is 130 and standard deviation of the English is 90. So 130 squared plus 90 squared, square root the whole number, and you get 158. So the answer here should be C. All right, next question here would be, skipping the second page. According to CBS New York Times, 15%, so P is equal to 0.15. In a random group of 5 people, so that is the total number of trials here, exactly 2. This is actually going to be a binomial CDF question where the number of trials is fixed. We have a percentage of people who's actually going to respond. And then we want to find out that the value is exactly 2. I'm sorry, this should be a PDF, not a CDF question. But now they gave it to me in terms of like something that's very weird. What this means is that it follows a formula that I showed you from before, not really going to be relevant for tomorrow, but it's good that you know this. Probability of x times 1 minus p to the power of n minus x, p being 0.15. So no matter what, you should have this as part of your answer choices. And since D and E is not, it doesn't really contain this, you're going to simply ignore those 2 answers. Now, where in the world does this come from is the probability is 0.15. The n is the total number of trials here. So that's going to be 5 and x is going to be the value. So that's going to be 2. If you plug in all those numbers respectively, you should get this here. Now, how do I calculate the combination of nx? Remember, that is on the math, PROB, and we're going to do number 3, NCR. We have 5 people and we're selecting 2, and the value of that becomes 10. And so this is going to be the correct answer. Or let's say if you don't remember that, if you were to just simply do binomial PDF, because you recognize that this is a binomial PDF question, and you do this, you get about a percentage. Now, if you actually take the answer choice number 1, and then you actually type this in, you get the exact same number. So that's how you can also tell that the answer choice A makes sense. All right, suppose you're 7.5 million people who send in their name. So one top prize for $1 million. So that's 1 out of 7.5 million people that you're able to win this prize. Not a lot, but it's still your probability times the value itself. Plus 5 out of 7.5 million people times 10,000 in this case. 20 over 7.5 million people times $100, and you're going to add all these together. So is it worth the 0.55 postage it costs you to send in your name? So first, let's apply this to the test. There's a lot of ways in which you can do this, but I'm just going to type this into my calculator here. 1 out of 750,000, and then I'm going to multiply that by 100,000. So that's your expected value of the first one. You're expected to gain about maybe 13 cents or so. 5 out of 7.5 million people, 00000 times 10,000. I think the biggest key here is to watch out for how many zeros you have, because it's really hard to tell. 20 out of 7.5 million, and multiply that by 100. You add 0.006666 plus 0.133333. And so your expected value is only about 14 cents. I think the answer here should be correct, B, because if your expected return is only about 14 cents, given the criteria for this game, if you're paying 55 cents, you're actually paying more than what you gain. So you're going to actually end up losing money. So you actually don't even want to try for this one. Last but not least, we have the basketball question. Now, there's a small typo here. This last one should have been 0.55. I forgot to mention. And so if you were to actually do this, a basketball makes a 55% of its 2-point attempts. Which expression will be used to find the probability of 12 out of its next 20 shots? Well, that's 20, 12. That's going to be your NX. You're having 20 shots. Out of those, you pick 12. This is definitely going to be a binomial PDF question once again. So probability of making is 0.55 raised to the power of 12, 0.45 raised to the power of 20 minus 12, which ends up becoming 8. So this is the correct answer, which is E. Okay, so hope this video helped. Make sure you guys focus on the FRQs. And if these questions were not so bad, expected value, combining them and finding the binomial PDF and such, I don't think you're going to have any problem for tomorrow. Good luck. And if I don't say this tomorrow to you guys, enjoy your spring weekend. The week after that, we're going to be working on a expected value project. And that should be it for the month of April, I believe. And we'll continue on from chapter 7 from that point onwards. Thank you guys and have a good day.